Hi everybody, welcome to the Manifold channel. Today we're going to take a look at Manifold's analogs to ESRI's distance tools in Spatial Analyst. In Manifold those are called the closest tools because they compute the various effects for pixels that are closest to each of some points in a drawing or map. And let's get right to it. We have here a map that's got two layers, a raster layer, which has a terrain elevation raster in it, and a points layer that's got a bunch of point objects in it. Let's zoom in closer to the raster layer. And what we're going to do is we're going to start by computing slope. The raster as it is shows terrain elevation. And to compute slope, we'll switch here to the transform pane, and I'll enter SL there to shorten the number of many transforms we have. I'll use a radius of 5 for the slope, and I'll change the name of this to slope so that the resultant layers will have short names to the layers. Yeah, that's better. And now let's create that slope. Click Add Component. And that quickly, it's done. And let's drag and drop the new slope raster into the map, and let's format this. I'll do everything here from beginning to end, so you see all the steps in the process. We'll use 12 breaks, and I will use a let's use the color brewer spectral palette. I like that one better, and I like a reverse color on that. So let's update style. And what we've just done is we've created a presentation of slope where brighter spots show more steeper terrain. For example, right here in the ridge, you can see that steep slope change. And blue spots show regions where the original terrain is kind of flat. That means the slope is very low values in the slope. And what we're now going to do is we're going to compute path distance throughout this region using the slope. What I want to do is I want to compute the distance from any pixel here in the raster to the nearest green point, and I want to do that all at once. So to do that, I'll use slope because I want to calculate that over slope for the path distance. So let's go right here to the transform pane again. I'll type SCL, and I want the closest path length, and I'm going to use points as my sources. I want to see that is the pixel path distance to the nearest point. And for cost, instead of using an equal cost, which will give me kind of like an Euclidean distance, I want to use the value of the slope as a cost, so that in order to find, say, the path from here to that point, it'll kind of go around the high cost areas and create paths that way. So once again, we will let's call this path length. I like short names instead of longer names. And let's call it this. That means the drawing will be called, the raster image will call it path length. Click OK, and now when I click Add Component, it's going to compute that, and it's done already. This takes considerably long in ESRI, and it happens really fast in Manifold because Manifold's parallelism is pretty darn fast. Let's drag and drop that into the map, and now let's style that again. And I'll do similar styling on channel 0. It's a single channel image with 12 breaks. And I will apply the color brewer spectral palette once more. Again, I'm going to reverse that because I prefer the reverse settings. And what I will do here is I will use hill shading with 0.02 as the z-scale. I know from experience it creates a nice effect. So what do we have here? We've created a terrain elevation surface, which is an abstract surface. It's not an elevation surface, it's a slope surface. So places where the terrain seems to be high, those are regions where there's high, this is the path length surface, and it was created from the slope surface. So from each dot here to the nearest green point, this terrain gives the distance in a path distance, that is path distance running around steep slope. And what this does is it divides the terrain into cells, where regions where it's kind of purple here are regions where pixels have a relatively close path distance to the dot. Regions which are very high, like over here, are regions where the path distance to the nearest dot is kind of high. And if you actually want to see the paths from any of these pixels to the nearest green dot, that's equivalent to computing a water length. That is a watershed length. And that's very easy to do. What we'll do is we'll compute watersheds on this path length, and WAT for watersheds. And let's create watershed lines, and you can see right away with previews. Manifold is so fast that if I want to see how many watershed lines I'll do, if I want more resolution or less resolution to them in terms of minimum flow, I can just change that right here, and it'll give me a preview in blue. It's not actually calculating; it's just giving me a preview. And I find that using watershed with a min flow of about 800 gives me enough watershed lines to be able to see what's going on without so many lines that it's cluttered. I like that, and let's call this shed lines. There we go. That's a good thing to do. And let's add component. And Manifold being parallel calculates that instantly. It's already done computing those watershed lines. Let's drag and drop those into the map. And let's format them. Let's style them with prettier color. We'll use this bright green color, and we'll make them about 0.75. And I like to use a halo around my lines. I like to use a black halo, which kind of gives a nice sort of bordered effect. And I think about 3 or 0.4 padding is about right. So that gives a nice effect to the lines. So what we see here, these watershed lines, gives us the shortest path, which reckons the cost of traversing high slopes. So they tend to go around high slopes, like you can see for here. For example, this path right here, from this point right here, instead of cutting across regions of where the slope is very high, and that's the slope right there. Instead of cutting across these high regions, it kind of follows along that same length, that same lower slope region to get this path right here. These are all the shortest distances when you add up the total cost of traversing high slope. And like this one here, this line here kind of goes in through this gap, and this one here kind of goes into that gap, and so forth. And if we want, we can see how these kind of are arranged in Voronoi cells by using the path source transform. And I'm going to compute that again on the slope. Let's go back here to the slope and closest path source. And let's call this path source. I like to use names which remind me what the heck all these layers are, because once you're fooling around with this stuff, you can create so many layers so quickly that you can forget what they all mean. And let's add that component. They are computed that instantly. It's remarkable how fast Manifold computes this stuff, by the way. It's just got to be seen as you're seeing right now to believe it. And let's change the style. Again, we're going to use channel 0. And for this one, I think I'll use unique values, and we'll use the altitude update style. And what the path source does, by the way, let's add some labels here for the point values. Each of these points has a z value in it, which is the altitude of the point. I just happen to use that. And what path source does is it simply takes the z value of the point and it puts it into all pixels which lie within the closest path to that particular grain point. So, for example, this pixel right here, which has an altitude of 346, all pixels which kind of drain into that by closest path will automatically be given that same value. So this is a way of kind of chopping up this region into these cells. And why do I do that? I do that because I want to have some nice borders in these regions, and to create those borders, I'm going to trace the areas of these raster regions using the trace areas transform. There it is right there. I'm going to do similarity of 1. And for the name of the output drawing, we would call it, let's just call it areas. That's about right. And click Add Component. It's done. And so now what I can do is I can drag and drop that areas into there, and I will format that so that the area backgrounds are transparent. And that gives me a nice border line. So you can see how all these things are divided into cells. And you can see how the slopes would be divided in terms of their shortest path to the nearest point by that, or adding the path length here. Let's do that right there. There. So now we've created in it's been 9 minutes into the video so far. If you if you discount the time that we spend for talking about this stuff and discussing it, in less than 5 minutes, we've created this display where we've first created a slope, and then we computed the path lengths through the shortest path, counting slope as path allocation cost, and then we have computed the watershed lines, which show the drainage patterns through those path length abstract surface to show the shortest paths from any given pixel to the nearest grain point. And then we computed path source, and we used that to trace areas to create a vector border. So we have a nice border that kind of delineates all the drainage regions, all the regions which are by closest path allocation cost to these grain points. And that's a whole lot of stuff to be able to do in just 5 minutes. Manifold is that fast, it's that convenient. We've colored everything, it looks really great. It's turn off the labels as you do. Let's do one more thing, by the way, while we're at it. I'll show you the new renaming features. Let's say I want to change the points labels. I want to rename points. I'm going to call that sources. I'll click rename sources, rename related, and here I'll change this to sources. And when I click that, all the related items like the table and the labels are automatically named, and that's already automatically updated in the in any layout that uses those layers, and in any map or anything else that uses those layers. So we can do all that quickly. Thanks for watching. I hope you've enjoyed this video. I understand it's very technical. If you're an ESRI person, this stuff is directly analogous to what's done at the Direction Tools and Spatial Analyst, only at a cost of about, I don't know, $5,000 a year more, and they're slower. What Manifold calls pixels, ESRI calls cells. ESRI also calls these path routes and so forth. So I hope you've enjoyed this video. Thanks for watching, and goodbye from the Manifold channel. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.